Welcome back, and in this lesson I want to talk to you about S3 pre-signed URLs. Pre-signed URLs are a way that you can give another person or application access to an object inside an S3 bucket using your credentials in a safe and secure way. Let's have a look at how this works architecturally. To illustrate how pre-signed URLs work, let's use this example architecture, an S3 bucket which doesn't have any public access configured, so it's still in a default private configuration. This means that in order to access the bucket or any resources in it, an IAM user such as IAM-admin would have to authenticate to AWS and be authorized to access the resource. IAM-admin would send credentials along with the access request, AWS would validate them at the time that the request is made, and only then grant access to the object in S3. Now, one issue that we have is that because the bucket is private, only authenticated users are able to access it. Our masked man here has no way of providing authentication information to AWS because he doesn't have any, and so any request that's unauthenticated would fail. Now, if giving the mystery user access to S3 is an essential requirement for the business, then there are three common solutions at this point, and none of them are ideal. Number one is to give the mystery user an AWS identity. Number two is to give the mystery user some AWS credentials to use. Or number three is to make the bucket or the object public. Now, none of these are ideal. If the user only needs short-term access to the bucket and objects, the effort of supplying an identity seems excessive. Just giving some credentials to the user appears on the surface to be a security risk, and definitely if it's somebody else's credentials, that's just bad practice. Making the bucket public for anything which has sensitive data in it also appears to be less than ideal. So one solution that AWS offers is to use pre-signed URLs. And let's look at how this would work with an architecture example. IAM-admin is an AWS identity with some access rights granted via a permissions policy. So IAM-admin can make a request to S3 to generate a pre-signed URL. She would need to provide her security credentials, specify a bucket name, an object key, and an expiry date and time, as well as indicate how the object would be accessed. And S3 will create a pre-signed URL and return it. This URL will have encoded inside it the details that IAM-admin provided, so which bucket it's for, which object it's for. It will be encoded with the fact that the IAM-admin user generated it, and it will be configured to expire at a certain date and time, as requested by the IAM-admin user. The URL could then be passed to our mystery user, and he or she could use it to access the specific object in the specific S3 bucket up until the point at which it expires. When the pre-signed URL is used, the holder of that URL is actually interacting with S3 as the person who generated it. So for that specific object in that specific bucket until the timer expires, our masked man is actually IAM-admin. Pre-signed URLs can be used for both downloads from S3, so GET operations, or uploads to S3, known as put operations. So this type of architecture might be useful for the Animals for Life remote workers if they don't have access to AWS accounts or are accessing from a secure location and just need to upload one specific object. Now, there's another type of architecture which commonly uses pre-signed URLs, and I've mentioned this earlier in the course when I was talking about some benefits of S3. I want you to think about a traditional application architecture. On the left, we have an application user with a laptop. We've got an application server in the public cloud in the middle, which hosts the application. And for example's sake, let's say this is a video processing application for wildlife videos that the Animals for Life organization manages. We've learned that one of the real strengths of S3 is its ability to host large media files, and so the large wildlife video files have been migrated from the application server to a media S3 bucket. But by doing this, we've introduced a problem. Previously, the videos were hosted on the application server, and it could control access to the video files. If we host them on an S3 bucket, then either every user needs an AWS identity, so an IAM user, to access the videos, or we need to make the videos public so that the user running the web application can download them into her browser, and neither of those are ideal. Luckily, pre-signed URLs offer a solution. With pre-signed URLs, we can keep the bucket private. Then we can create an IAM user in our AWS account for this application. Remember when I talked about choosing between an IAM user or a role, I said that if you could visualize how many of a certain thing that would be using an identity, then it's likely to suit an IAM user. Well, in this case, we have one application, and application service accounts are a common scenario where IAM users are used. So, for this example, we create an IAM user for the application. So when our application user interacts with the web application, she makes a request, and that's step one. The request might be for a page of information on a bushfire which is currently happening in Australia, which has a video file associated with it. The application that's running on the server knows that it can directly return the information that the request is asking for, but that the video is hosted on the private S3 bucket. So it initiates a request to S3 asking for it to generate a pre-signed URL for that particular video object, using the permissions of the IAM user that the application is using, so IAM app1. The S3 service then creates a URL which has encoded within it the authentication information for the IAM app1 user, the access to one object in the bucket for a short time-limited basis, maybe 2 to 3 hours. And the S3 service then returns that to the application server and through to the end user. The web application that's running on the user's laptop then uses this pre-signed URL to securely access the particular object that's stored on the media bucket. Pre-signed URLs are often used when you offload media into S3 or as part of serverless architectures where access to a private S3 bucket needs to be controlled and you don't want to run thick application servers to broker that access. And we'll look at serverless architectures later in the course. For now, I just want to be sure that you understand what pre-signed URLs do, and in the next lesson, which is a demo lesson, you're going to get the chance to experiment yourself and generate a pre-signed URL. Pre-signed URLs can be used to access an object in a private S3 bucket with the access rights of the identity which generates them. They're time limited and they encode all of the authentication information needed inside. And they can be used to upload objects and download objects from S3. Now I want to show you this in a demo because it's far easier to actually do it. But before we do that, I want to step through some exam power-ups. There are a couple of really interesting facts about generating pre-signed URLs which might help you out in some exam questions. Now first, and this is a fairly odd behaviour, but you can create a pre-signed URL for an object that you have no access to. The only requirement for generating a pre-signed URL is that you specify a particular object and an expiry date and time. If you don't have access to that object, you can still generate a pre-signed URL, which also, because it's linked to you, will have no access to that object. So there aren't many use cases where this is applicable, but you do need to be aware that it is possible to generate a pre-signed URL when you don't have any access. Now, when you're using the URL, so when you utilize a URL and attempt to access an object, the permissions that you have access to match the identity that generated it. And it's important to understand that it matches the permissions that the identity has right now. So at the point when you use the URL has the same permissions as the identity that generated it has right now. So if you get an access denied error when you attempt to use a pre-signed URL to access an object, it could be that the identity that generated that URL never had access, or it could be that it simply doesn't have access right now. And they're two very important nuances to understand about pre-signed URLs. So when you're using a URL to access an object, it matches the current permissions of the identity that generated that URL. Now that's fairly okay for an IAM user. As I demonstrated on the previous example of the application, generally you would create an IAM user for the application, and this IAM user would have fairly static permissions. So the permissions generally wouldn't change between when you created the URL and when your customer is using that URL within an application. But don't generate pre-signed URLs based on an IAM role. You can, in theory, assume an IAM role, which, remember, gives you temporary credentials, and then you can use those temporary credentials to generate a pre-signed URL. A pre-signed URL can have a much longer validity period than those temporary credentials. So those temporary credentials will generally expire well before a pre-signed URL does. So if you generate a pre-signed URL using a role and then those temporary credentials expire, those credentials are no longer valid, and so that URL will stop working. And so it's almost never a good idea to generate a pre-signed URL using an IAM role. You should always use long-term identities, so generally an IAM user. With that being said though, that is everything that I wanted to cover in this theory lesson, so go ahead, complete the video, and when you're ready, I'll look forward to you joining me in the next.